students, let's start off with trigonometric functions, chapter 3, exercise 3.3. So in this exercise we'll have some formulas. Those formulas we'll be just learning about those formulas. I'll write all those formulas, what are the formulas to be used in this exercise. We know about the different identities, we know about when it is in different quadrants, so all those we'll just have a look at all of them. So the first one is Pythagorean identities. What are the three Pythagorean identities which we're having? We'll see, because we'll be using all these identities usually in all types of problems wherever trigonometry is there. So the first one is sin square theta plus cos square theta is equal to 1. The second identity is 1 plus tan square theta is equal to secant square theta. And the third one is 1 plus cot square theta is equal to cosecant square theta. So you can write down whichever method it's needed. We can write it also as secant square theta minus tan square theta is equal to 1, cosecant square theta minus cot square theta is equal to 1, or cos square theta can be written as 1 minus sin square, and sin square theta can be written as 1 minus cos square. So even and odd angle formulas, what are those? We'll just see. Sine of minus theta is equal to minus sin theta. Cos of minus theta is equal to cos theta. So only for cos theta and secant theta will have positive whenever it is taken with a negative angle. So tan of minus theta is equal to minus tan theta, and cot of minus theta is equal to minus cot theta. Secant of minus theta is equal to secant theta, and cosecant of theta minus theta is equal to minus cosecant theta. Next we have what is cofunction formulas. So what are these cofunction formulas? We'll see. Sine of 90 minus theta is equal to cos theta. This sine and cos are cofunctions, so you get them when sine 90 minus theta is taken, you get cos. When cos 90 minus theta is equal, you will get sine. So therefore sine 90 minus theta is equal cos theta, cos 90 minus theta is equal sine. Tan 90 minus theta is cot theta, cot 90 minus theta is equal to tan theta we get, because these tan and cot are cofunctions. And secant 90 minus theta is equal to cosecant theta. Cosecant 90 minus theta is equal to secant theta. Now we'll see what are double angle formulas. All these formulas are usually used in trigonometry, so we have to know all these formulas. Sine 2 theta, which is double angle, is equal to 2 sin theta cos theta. Cos 2 theta is equal to 1 minus 2 sin square theta, and tan 2 theta is equal to 2 tan theta by 1 minus tan square theta. Next we have what are called as half angle formulas. What are these half angle formulas also we'll see. So sin theta is equal to plus or minus under root of 1 minus cos 2 theta by 2, and cos theta is equal to plus or minus root of 1 plus cos 2 theta by 2. Then we have what is called as tan theta. Tan theta is equal to plus or minus root of 1 minus cos 2 theta by 1 plus cos 2 theta. Next we'll see what is thrice of angle formula. So how do we take these formulas? We'll see. So first we'll have what is sine 3 theta is equal to 3 sine theta minus 4 sine cube theta. Then we have cos 3 theta is equal to 4 cos cube theta minus 3 cos theta. Then we have what is called as tan 3 theta. Tan 3 theta is equal to 3 tan theta minus tan cube theta by 1 minus 3 tan square theta. Cot 3 theta is equal to cot cube theta minus 3 cot theta by 3 cot square theta minus 1. Next we have some important formulas, sum and difference formulas. These are very important here when we are using this in exercise 3.3. we'll be using these formulas. We'll be using most of these formulas, but you have to know these more frequently. We'll be using them. So sin a plus b is equal to sin a cos b plus cos a sin b. This is the first formula which we have. Next we have what is sine of a minus b. So sine of a minus b is equal to sin a cos b minus cos a sin b. Then we have what is cos of a plus b, which is equal to cos a cos b minus sin a sin b. Next, cos of a minus b is equal to cos a cos b plus sin a sin b. Then tan a plus b is equal to tan a plus tan b by 1 minus tan a tan b. Tan a minus b is equal to tan a minus tan b divided by 1 plus tan a tan b. Now let's go into product to sum formulas. Sin a into sin b is equal to half cos a minus b minus cos a plus b. Then we have cos a into cos b is equal to half into cos a minus b plus cos a plus b. So these are product to sum formulas. Then we have sin a cos b also, combination of sin and cos. This is half of sin a plus b minus plus sin a minus b. Then we have what is cos a sin b equal to half into sin a plus b minus sin a minus b. So combination of both sin and cos will give you sin, sum and subtraction, and both sin a cos a will give you sin a sin b will give you cos. Okay, sum to product formulas. Sin a plus sin b is equal to 2 sin a plus b by 2 into cos a minus b by 2. Sin a minus sin b is equal to 2 cos a plus b by 2 into sin a minus b by 2. We'll be using all these formulas in this exercise 3.3. So cos A plus cos B is equal to 2 cos A plus B by 2 into cos A minus B by 2. Then cos A minus cos B is equal to 2 sin minus 2 sin A plus B by 2 into sin A minus B by 2. So trigonometric functions exercise 3.3. First problem, prove that sin square pi by 6 plus cos square pi by 3 minus tan square pi by 4 is equal to minus 1 by 2. So in order to solve this problem, the solution part over here we can take what are the values of each and every trigonometric function. That is, sin pi by 6 is nothing but sin 180 by 6, which is equal to sin 30, which is equal to half. Cos pi by 3 is equal to cos 60, which is equal to 1 by 2. And tan pi by 4 is nothing but tan 45, which is equal to 1. So now here it's given that we have to prove that sin square pi by 6 plus cos square pi by 3 minus tan square pi by 4 is equal to minus 1 by 2. So now taking LHS over here first, LHS is equal to half whole square, that is sin square pi by 6 plus 1 by 2 whole square minus 1, which is equal to 1 by 4 plus 1 by 4 minus 1. 1 by 4 plus 1 by 4 is 1 by 2 minus 1, which is equal to minus half, which is equal to RHS. So since LHS is equal to RHS, hence proved. So going now into the second problem. What is the second problem? We'll see. This is the first problem which we did. So now second one is, prove that 2 sin square pi by 6 plus cosecant square 7 pi by 6 cos square pi by 3 is equal to 3 by 2. So now in the solution part over here, you can consider what is first. We'll take the values. What are the different values? Sin pi by 6 means it's equal to 180 by 6, which is equal to sin 30, which is equal to half. Next again, cosecant 7 pi by 6 can be written as, it can be written in the form of cosecant 6 pi plus pi by 6. So 6 pi by 6 will give you cosecant pi plus pi by 6. So now 180 plus pi by 6 cosecant 180 plus. So here it is equal to, you are having cosecant all silver teacups. So it's in the third quadrant. So here you will get it as only tan and secant will be positive, or the remaining all will be minus. So minus cosecant pi by 6, which is equal to minus of cosecant of 30, which is equal to minus 2 is the answer for this. Now next we can go into what is the next value which we have to calculate, that is cos of pi by 3. Cos of pi by 3 is nothing but cos of 60, which is equal to 1 by 2. Now substituting all the values in the LHS. So LHS is equal to 2 into half whole square plus, we having here, this is minus 2 whole square into 1 by 2. So which is equal to 2 into 1 by 4 plus 4 into 1 by 4. So 4 will get cancelled here, and 2 and here 2. So it is equal to half plus 1, which is equal to 3 by 2. So this is the answer which we got for this, which is equal to RHS. So we can write that this is equal to RHS. So LHS is equal to RHS. now going into the next problem, that is the third problem. What is the third problem we'll look into? Third problem, prove that cot square pi by 6 plus cosecant 5 pi by 6 plus 3 tan square pi by 6 is equal to 6. So in order to do this, how will we do? We'll write down all the values of what is cot pi by 6, cosecant pi by 6, 5 pi by 6 and tan pi by 6 separately, and then we'll substitute in this LHS. So cot pi by 6 is nothing but cot of 30, which is equal to root 3. Then you're having cosecant 5 pi by 6 can be written as 6 pi cosecant of 6 pi minus pi by 6. So here this can be equal to cosecant of pi minus pi by 6. So 180 minus theta, cosecant of 180 minus theta is again cosecant theta. Here you will get a positive value because it lies in the second quadrant. Therefore, here it will be equal to positive. So cosecant of pi by 6 will get over here. Which is equal to 2. So therefore tan pi by 6 is nothing but tan of 30, which is equal to root 3. Now substituting in the LHS, so LHS is equal to, you are going to get it as cot square pi by 6, that is root 3 whole square plus 2 plus 1 by root 3 whole square. So root 3 whole square plus 2 plus 3 into root 3 whole square. So now here this is 3 plus 2 plus that 3 will get cancelled over there. So it is equal to 6. You are getting the answer, which is equal to RHS. Hence proved. Since the LHS is equal to RHS, hence it is proved. Now going into the fourth problem. What's the fourth problem? Let's see. Prove that 2 sin square 3 pi by 4 plus 2 cos square pi by 4 plus 2 secant square pi by 3 is equal to 10. So now how do we go into the solution part of this? We'll see what is the solution of this. We'll write down each and every value of sin 3 pi by 4, cos pi by 4 and secant pi by 3. What are all these values? We'll see. So starting off with sin 3 pi by 4, which is equal to sine of 4 pi minus pi by 4, which is equal to sine of 180 minus 45, that is pi by 4, which is equal to 180 minus means it becomes there. Again you will be getting it as sine pi by 4. It is positive in the second quadrant. So which is equal to sine 45, which is equal to 1 by root 2. Next, cos of pi by 4, that means cos of 45, which is equal to 1 by root 2. Next we have what is secant of pi by 3, which is equal to secant 60, which is equal to 2. Therefore LHS is equal to, what is LHS equal to? 2 into 1 by root 2 whole square plus 2 into 1 by root 2 whole square plus 2 into 2 square. So we can write as 2 into 1 by root 2 whole square plus 2 into 1 by root 2 whole square plus 2 into 2 square. So which is, here you will get it as 2 into 1 by 2 plus 2 into 1 by 2 plus 4 2s are 8. So total the answer will be here 10, because 1 plus 1 plus 8 is equal to 10 is the answer, which is equal to RHS. Therefore LHS is equal to RHS, hence proved. So next, going into the fifth problem. What is the fifth problem? Let's see. Find the value of sine 75 degrees, tan 15 degrees. Now we'll be using the sum formula for this. Sin A plus B formula. So here now first one we have sin A plus B is equal to, or sin 75 can be written as sin of 45 plus 30. So 45 plus 30, which is equal to sin A sin B plus cos A cos B. So sin 45 into cos 30, I'm sorry, sin A plus B is equal to sin A cos B plus cos A sin B. So therefore sin 45 into cos 30 plus cos 45 into sin 30. So cos 40 sin 45 is nothing but 1 by root 2. Here I am writing the formula also. Sin of A plus B is equal sin A plus B is equal to sin A cos B plus cos A sin B. So now substituting the value, sin 45 is equal to 1 by root 2. Cos 30 is equal to root 3 by 2 plus 1 by root 2 into half. So in the denominator having 2 root 2. So in the numerator you will be getting it as root 3 plus 1 divided by 2 root 2 is the answer. Now going in the second one, the tan 15 degrees. So here you can write it as tan 45 minus 30. So here you have to use tan A minus tan B formula, which is equal to tan A plus tan B divided by tan A minus tan B divided by 1 plus tan A into tan B. So here tan 45 minus 30 is equal to tan 45 minus 30, which is equal to tan 45 minus tan 30 divided by 1 minus tan 45, 1 plus tan 45 into tan 30. So tan 45 is equal to 1 minus of tan 30 is 1 by root 3 divided by 1 plus 1 into 1 by root 3, which is equal to root 3 minus 1 divided by root 3 by root 3 plus 1 divided by root 3, which is root 3 will get cancelled. So you are getting root 3 minus 1 by root 3 plus 1. If you rationalize this, the denominator you will be getting it as, the rationalizing factor as root 3 minus 1 by root 3 minus 1. Which is equal to root 3 minus 1 whole square divided by root 3 whole square minus 1, that is 3 minus 1. So you are getting in the numerator as 3 plus 1 minus 2 root 3 divided by 2. So 4 minus 2 root 3 by 2, which is equal to 2 minus root 3. So this is the answer which we got. Next one, prove that cos of pi by 4 minus x into cos of pi by 4 minus y minus sin pi by 4 minus x into sin pi by 4 minus y is equal to sin x plus y. So we'll be using this sum or difference formulas over here, and we'll write down all the values whatever we're getting in the solution part. So what are all those values, we'll see. So here you can put pi by 4 is equal to a. Not pi by 4, we'll put it as pi by 4 minus x as equal to a, and pi by 4 minus y by equal to b. So here you are getting cos a cos b minus sin a sin b. LHS is equal to cos a into cos b minus sin a into sin b, which is equal to cos of a plus b. which is equal to, what is a now? We have written it as pi by 4. So cos of pi by 4 minus x plus pi by 4 minus y, which is equal to pi by 4 plus pi by 4 is pi by 2. So cos of pi by 2 minus of x plus y. So cos of 90 minus theta will give you sin 90 minus sin theta, so which is equal to sin of x plus y, which is equal to our RHS, hence proved. Since sin of cos of 90 minus theta is equal to sin theta. Which is equal to RHS, hence proved. Cos 90 minus theta can also be written as cos pi by 2 minus theta, which is equal to sin theta. That only we have written. Cos of 90 minus x plus y will give you sin x plus y. Going to the seventh problem. Prove that tan pi by 4 plus x by tan pi by 4 minus x is equal to 1 plus tan x by 1 minus tan x whole square. So in the solution part, what do we have? We'll see. Solution over here. Now we'll expand tan a plus b formula using tan a plus b formula. What is tan pi by 4 plus x by tan pi by 4 minus x, so which is equal to, so here you can write it as tan a plus b is equal to tan a plus tan b by 1 minus tan a tan b. So tan pi by 4 plus tan x by 1 minus tan pi by 4 tan x by tan pi by 4 minus tan x by 1 minus, I'm sorry, 1 plus, because this is a minus b, isn't it? So 1 plus tan pi by 4 into tan x. That is a by b by c by d is equal to ad by bc. So which is equal to, you can write as tan pi by 4 is what? You have to write each and every value of the tan pi by 4 is nothing but tan 45. So you'll be getting it as equal to 1 plus tan x by 1 minus tan x so you know tan pi by 4 is equal to 1, which is tan 45, it is equal to 1. So therefore you can write as wherever tan pi by 4 is there, you write it as 1. So 1 plus tan x by 1 minus tan x by 1 minus tan x by 1 plus tan x. So now you know that a by b by c by d is equal to ad by bc. So you can write this as 1 plus tan x whole square by 1 minus tan x whole square. And this is nothing but it is equal to RHS. Therefore LHS is equal to RHS. Now moving on to the next problem, that is the eighth one. Prove that cos of pi plus x into cos minus x by sin pi minus x into cos pi by 2 plus x is equal to cot square x. So here you are having cos a plus b we have to do, and a minus b also will be using over here. So we will be using these formulas. Solution part, LHS is equal to cos pi plus x into cos minus x divided by even or odd functions. We have this formulas. In those formulas we have what is cos of minus x by sin pi minus x into cos pi by 2 plus x, that is 90 plus theta. So whenever cos of 90 plus theta is there, the sign also will change, the formula will become, it will be changed. You'll have a different, in cos you'll have sin. So now here cos of pi plus x is equal to minus cos x. This is in third quadrant. So therefore cos is minus over there, into cos of minus x is equal to cos x by sin x into, again it is sin x. because cos pi by 2 90 plus theta, cos 90 plus theta is equal to minus sin x. So in the numerator you are having cos square x by minus cos square x by minus sin square x. So here minus minus will get cancelled, therefore it is equal to cot square x, and this is nothing but it's equal to RHS. So therefore LHS is equal to RHS. Next, going to the next problem, that is the ninth. Prove that cos 3 pi by 2 plus x into cos 2 pi plus x into cot 3 pi by 2 minus x plus cos 2 pi plus x is equal to 1. So now here in the solution part you are having different formulas here, where you use cos a plus b, cos cot a plus a minus b. So all these formulas will be using. So LHS is equal to what we will get, we'll see. Cos 3 pi by 2 plus x is equal to into cos 2 pi plus x. So in brackets you are having again cot of 3 pi by 2 minus x plus cot 2 pi plus x. So it is equal to cos 3 pi by 2 plus x is equal to, you have again here in the brackets you can write as cot 3 pi by 2 minus x plus cot 2 pi plus x, which is equal to cos 3 pi by 2 plus x is equal to sin x into cos x into tan x plus so 3 pi by 2 is nothing but 270 plus x. So you are having cos of 270 plus x is sin x, and cos of 2 pi plus x, that is 360 plus x, is again cos x itself. Here cot of 270 minus x is equal to tan x, and cot of 2 pi plus x, again you will get back cot itself, cot x. So which is equal to sin x into cos x into sin x by cos x plus cos x by sin x. So when you are cancelling the terms over here, you will get sin square x plus cos square x. So if you are taking the LCM also, you will be getting it in that way, or you multiply also, you will get the same thing. So therefore you are getting sin square x plus cos square x is equal to 1. So therefore the answer is equal to sin x into cos x by sin x into cos x, which is equal to 1, because this will get cancelled. You can also take it inside only the sin x cos x into sin x by cos x, will get sin square x plus cos square x directly. Now 10th one, prove that sin n plus 1x into sin n plus 2x plus cos n plus 1x into cos n plus 2x is equal to cos x. So we are in the solution part, you have here n plus 1 into x, let it be equal to a, and n plus 2 into x be b. So here you can write the formula as LHS is equal to cos sin a into sin b plus cos a into cos b. So which is equal to, you are going to get it as sin of a into sin b plus cos a into cos b. It's written in that form. So therefore you will be getting it as cos of a minus b. So therefore cos of n plus 1 into x minus n plus 2 into x, because a is nothing but n plus 1 into x and b is n plus 2 into x. So therefore cos of nx plus n minus nx minus 2x. So you are getting nx and x cancel, and x minus of 2x is cos of minus x, and cos of minus x is nothing but equal to cos x itself. From the formulas we have this, therefore that is equal to RHS. Now going into the 11th one, prove that cos of 3 pi by 4 plus x minus cos of 3 pi by 4 minus x is equal to minus root 2 sin x. So in the solution part we have here LHS is equal to cos 3 pi by 4 plus x, that is cos 270 plus x, which is sin x you are getting, and minus 270 minus x is equal to cos 3 pi by 4x into cos x, minus we are expanding it as cos a cos b minus sin a sin b, that is cos 3 pi by 4 plus x, we are expanding it like that. So cos 3 pi by 4 into cos x minus sin 3 pi by 4 into sin x minus cos 3 pi by 4. Now we are expanding the second one, that is cos of 3 pi by 4 minus x. So therefore this is equal to cos 3 pi by 4 into cos x plus sin of 3 pi by 4 into sin x. So that is equal to cos 3 pi by 4 into cos x minus sin 3 pi by 4 into sin x minus cos 3 pi by 4 into cos x minus sin 3 pi by 4 into sin x. So therefore the first and the third term will get cancelled because they are same. Therefore getting minus 2 into sin 3 pi by 4 x into sin x. So you can write this as minus 2 into sin 3 pi by 4 can be written as 4 pi minus pi by 4, and which can be written as sin of pi minus pi by 4 into sin x. So therefore minus 2 into sin 180 minus theta is equal to sin theta, that is sin pi by 4 into sin x. So sin 45 is nothing but root 1 by root 2 minus 2 into 1 by root 2 into sin x. So this will get cancelled. So the answer is minus root 2 sin x is the answer. Now going into the 12th one, prove that sin square 6x minus sin square 4x is equal to sin 2x sin 10x. So how do we do this problem? We'll see in the solution part. So what's the solution? We'll write down here. Solution of this is equal to, here sin square 6x you're having, sin square 6x minus sin square 4x is equal to sin 6x plus 4x into sin 6x minus 4x. So since sin square a minus sin square b is equal to sin a plus b into sin a minus b. So sin 6x plus 4x is equal to sin 10x, and sin 6x minus 4x is equal to sin 2x. So that is sin 10x sin 2x, which is equal to RHS. Hence proved. Now going into the 13th one, prove that cos square 2x minus cos square 6x is equal to sin 4x sin 8x. So cos square 2x minus cos square 6x is, we'll take LHS first. So cos square x. So now cos square 2x minus cos square 6x can be written in the form of cos square a minus cos square b, but we don't have a direct formula like we can write for sin square b and sin square a minus sin square b. For this it's not equal to cos a plus b minus cos a minus b. We can write cos square a as 1 minus sin square a minus 1 minus sin square b. So in that way we have to write and then expand it using sin a, sin square a, sin square b minus sin square b. So therefore you can use that formula over there. You know that cos square x can be written as 1 minus sin square x. So therefore it's written as 1 minus sin square 3x, 2x minus 1 minus sin square 6x. So now here when you expand this, it's equal to 1 minus sin square 2x minus 1 plus sin square 6x. So now here minus 1 will get cancelled. So this is equal to sin square 2x plus sin square 6x. Here you are having a minus sign for sin square 2x. So therefore you can write as, because plus is for sin square 6x, you can write it as sin square 6x minus sin square 2x. So now therefore you know there is a formula, sin square a minus sin square b is equal to sin square a plus b minus, sin a plus b minus into sin a minus b. So this is the formula we can use. So that's equal to sin of 6x plus 2x into sin of 6x minus 2x. So therefore you are getting sin 8x into sin 4x. So this is the answer which we got. It's equal to RHS. Now going into the 14th problem. What's the 14th problem? Prove that sin 2x plus 2 sin 4x plus sin 6x is equal to 4 cos square x sin 4x. So here in the solution part, how do we write it? We'll just look into the what we can use here, which formula we'll use. While writing the steps we'll see. So therefore here you are having sin 2x plus sin 6x I am taking first, because it's in form sin a plus sin b plus 2 sin 4x is equal to, now sin 2x plus sin 6x can be written as 2 sin 6x plus 2x by 2 into cos 6x minus 2x by 2. So this is equal to 2 sin 8x by 2 sin c plus sin d formula we are using here, which is equal to 2 sin c plus d by 2 into sin c minus d by 2. So now what is this equal to? We can write as 2 sin 8x by 2 into cos 4x by 2 plus 2 sin 4x. And you know 8x by 2 is nothing but 4x. So therefore 2 into sin 4x, and 4x by 2 can be written as 2x. So into cos 2x plus 2 sin 4x. Now sin 4x we can take out common in both of them. So we are going to get it as 2 sin 4x, because 2 is also common. It will become cos 2x plus 1. Now this can be written as 2 sin 4x. Cos 2x can be written as 2 cos square minus 1 plus 1. Since cos 2x is equal to 2 cos square x minus 1. So therefore this is equal to 2 sin 4x into cos square x into sin 4x. This will be the answer, which is equal to RHS. Hence proved. Yeah, the 15th problem. Looking at the 15th problem. What is the 15th problem? Prove that cot 4x into sin 5x plus sin 3x is equal to cot x into sin 5x minus sin 3x. So now here the solution for this. How do we go about with the solution? We know that sin c, since sin c plus sin d can be written as 2 into sin c plus d by 2 into cos c minus d by 2. So therefore we'll put this in this formula over here. You are having LHS is equal to cot 4x into sin 5x plus sin 3x. So for sin 5x plus sin 3x, we'll apply this formula. So cot 4x into, we'll get it as 2 into sine 5x plus 3x divided by 2 into cos 5x minus 3x divided by 2. So which is equal to cot of 4x into 2 into sine 8x by 2 into cos 2x by 2, which can be written as cot of 4x into 2 into sine 4x into cos 2x. So this can be written as cos 4x by sine 4x into 2 into sine 4x into cos, here 2x means here this becomes x, I'm sorry, because 2 will get cancelled and here it is 4, so this becomes only x over here. So sine 4x and this will get cancelled, so we are getting it as equal to 2 cos 4x into cos x. Now going into the right hand side, what is the right hand side given to us? We are given that cot x into sine 5x minus sine 3x, cot x into sine 5x minus sine 3x. So we also know since sine c minus sine d is equal to 2 cos c plus d by 2 into sine c minus d by 2. So you can write this as equal to cot x into 2 cos 5x plus 3x by 2 into sine 5x minus 3x by 2. So which is equal to cot x into 2 into cos 8x by 2 is nothing but 4x into sine 2x by 2 is sine x. So this can be written as cos x by sine x into 2 into cos 4x into sine x. So sine x and sine x is getting cancelled, so you're going to get it as 2 into cos 4x into cos x. So therefore this is nothing but from, if you take this as equation 2 and what we got here is equation 1, so from 1 and 2 we can see that from 1 and 2 we get LHS is equal to RHS, which is equal to 2 into cos 4x into cos x. So now going into the 16th one. What's this? When you have 16th one, you have to prove that cos 9x minus cos 5x by sin 17x minus sin 3x is equal to minus sin 2x by cos 10x. So we have to use the formulas. So we are what we having first here, LHS is equal to cos 9x minus cos 5x by sin 17x minus sin 3x. So now here we can use here the formula of cos c minus d. So here first we having cos, since cos c minus d is equal to, I'm sorry, cos c minus cos d is equal to minus 2 of sin c plus d by 2 into sin c minus d by 2. And we also have here, since sin c minus sin d can be written as equal to 2 cos of c plus d by 2 into sin c minus d by 2. So using these formulas, we'll apply in this above formula. LHS is equal to this, so which is equal to, you can write it as equal to minus 2 sine of 9x plus 5x by 2 into sine of 9x minus 5x by 2 divided by 2 into cos of divided by 2 into cos of 17x plus 3x by 2 into sine of 17x minus 3x by 2. So which is equal to, here 2 can get cancelled. So you're getting it as minus sine 9 plus 5 is 14 by 2, which is 7x, into sine here 4x by 2 means sine 2x, divided by cos 17x plus, so it is 20 by 2 means cos 10x, and here you are getting sine 17x minus 3x is 14x by 2, which is sine 7x. So sin x and this will get cancelled, so which is equal to minus sine 2x by cos 10x, which is equal to RHS, hence proved. So now going into the next problem. So going into the 17th problem, we have proved that sine 5x plus sine 3x by cos 5x plus cos 3x is equal to tan 4x. So in the solution part, here you have again using the c minus d and c plus d formulas we can do using the c plus d formula. So here you get it as sine of c plus sine d is equal to 2 sine c plus d by 2 into cos c minus d by 2, and you also have that cos c plus cos d is equal to, since we are taking this, it's equal to 2 of cos c plus d by 2 into cos c minus d by 2. So using these formulas, we'll just see what we are getting. So LHS is equal to sine 5x plus sine 3x divided by cos 5x plus cos 3x, which is equal to, here I am writing it as 2 sine 5x plus 3x by 2 into cos 5x minus 3x by 2 divided by 2 into cos 5x plus 3x by 2 into cos 5x minus 3x by 2. So which is equal to 2 will get cancelled over here. So you're going to get it as sine 8x by 2, which is sine 4x, into sine 2x by 2 is sine cos, into cos x, divided by, here again it is cos 4x, into, again here you are getting it as cos of x. So cos x is getting sine 4x by cos 4x is nothing but tan 4x, which is equal to RHS. So here you are having 18th one, prove that sin x minus sin y is by cos x plus cos y is equal to tan x minus y by 2. So what, here again we use the same c minus d formula, c plus d. So you are having here, since sin c minus sin d formula, if you are using this, you are getting it as, it's equal to 2 of cos c plus d by 2 into sin c minus d by 2, and also having cos c plus cos d is equal to 2 cos of c plus d by 2 into cos c minus d by 2. So you are getting here LHS is equal to, from this you are having, from LHS here you are having sin x minus sin y divided by cos x plus cos y is equal to 2 cos x plus y by 2 into sin x minus y by 2 divided by 2 cos x plus y by 2 into cos x minus y by 2. So here 2 will get cancelled, this will get cancelled, so you are getting here tan x minus y by 2, which is equal to RHS. Prove that sin x plus sin 3x by cos x plus cos 3x is equal to tan 2x. So now in the solution part we have here solution. Here again we have to use sin c plus sin d, which is equal to 2 sin c plus d by 2 into cos c minus d by 2, and we have in the denominator cos c plus cos d, which is equal to 2 cos c plus d by 2 into cos c minus d by 2. So using this formulas we'll be putting in this. So therefore LHS is equal to sin x plus sin 3x by cos x plus cos 3x is equal to, using the formula we can write this as 2 into sin x plus 3x by 2 into cos x minus 3x by 2 divided by 2 into cos x plus 3x by 2 into cos x minus 3x by 2. So this 2 will get cancelled. You're going to get it as sin 2x, 4x by 2 is 2x into cos minus 2x by 2 by cos 2x, because cos 4x by 2 is cos 2x into cos minus 2x by 2, which is equal to minus x. So therefore these two are same, so you can cancel out. You are getting it as tan 2x, which is equal to RHS. Hence proved. Prove that sin x minus sin 3x by sin square x minus cos square x is equal to 2 sin x. So now here you have in the solution part, here again if you use sin c minus sin d, it is equal to 2 cos c plus d by 2 into sin c minus d by 2. So this is for sin c minus sin d, and we have sin square. You can write this as cos 2x is equal to cos square x minus sin square x. So therefore while writing this, how do we write this, we'll just see. So this is equal to, over here first taking the LHS side using both the above formulas. What is the LHS we have here? It's equal to sin x minus sin 3x divided by sin square x minus cos square x. So we have this. So this is equal to, you can use this formula now. Here you are having it as, you can write this as in this way, minus of sin 3x minus sin x. You are multiplying with the minus sign in the numerator and denominator so that we can apply the formulas easily. So this is equal to this. So now in the numerator this is equal to, you're getting this as, this minus sign will get cancelled. So it is sin c minus sin d. So you're going to get it as 2 into cos 3x plus x by 2 into sin 3x minus x by 2 divided by, now cos square minus sin square x is nothing but cos 2x. We have already seen this. So this is equal to 2 into, you're going to get it as cos 4x by 2 is nothing but 2 cos 2x into sin 2x by 2 is nothing but sin x divided by cos 2x. So cos 2x will get cancelled. So the answer is 2 into sin x, which is equal to RHS. So therefore LHS is equal to RH. So the 21st problem we have here, prove that cos 4x plus cos 3x plus cos 2x by sin 4x plus sin 3x plus sin 2x is equal to cot 3x. So what will we do here is we are going to take it as first cos 4x plus cos 2x will do. So we can write this as we'll apply for first taking the LHS here. We can write it as cos 4x plus cos 2x plus cos 3x divided by sin 4x plus sin 2x plus sin 3x. So we are taking this 4x and 2x together so that we can get a positive value, because it's divided by 2. We'll be getting it as cos c plus cos d. You'll get 2 cos c plus d by 2 into cos c minus d by 2. So if you're taking both even numbers, you'll be getting an even, you can divide it by 2 easily. So therefore this we can take it in this way as equal to, you know that cos c plus cos d is equal to 2 cos of c plus d by 2 into cos of c minus d by 2. And what is sin c plus sin d is equal to 2 sin c plus d by 2 into cos c minus d by 2. So using these two formulas we'll apply into this. So it is equal to 2 cos of 4x plus 2x by 2 into cos of 4x minus 2x by 2 divided by sin 4x plus sin 2x. We can write it as 2 into sin 4x plus 2x by 2 into cos 4x minus 2x by 2. Here you are having here in the numerator here plus cos 3x plus here sin 3x. So therefore this is equal to, you can write this as 2 into cos 6x by 2 is nothing but cos 3x into cos 2x by 2 is cos x plus cos 3x divided by 2 sin 3x into cos x plus sin 3x. So now taking cos 3x common, taking cos 3x common, in the numerator and sin 3x common in the denominator, we get to cos 3x. If I take out common here, you are getting it as cos x plus 1, and in the denominator also if I take sin 3x common, you are going to get it as cos x plus 1. So cos x will get, so cos x by sin 3x is nothing but cot of 3x, which is equal to RHS. So hence proved. LHS is equal to RHS. So therefore this is proved. Now going second problem, we'll see. Prove that cot x into cot 2x minus cot 2x cot 3x minus cot 3x cot x is equal to 1. So here the solution part, so cot 3x can be written as cot 2x plus x. So therefore here it implies, therefore cot 3x is equal to cot 2x into cot x minus 1 divided by cot x plus cot 2x, because you know that cot of a plus b is equal to cot A cot B minus 1 divided by cot A plus cot B. So now here you're having, if you're cross multiplying this, now you can cross multiply this. So what are we getting? We'll see. Therefore you will get cot 3x into cot x plus cot 2x is equal to cot 2x into cot x minus 1. So now you can multiply it inside. Cot 3x into cot x plus cot 3x into cot 2x is equal to cot 2x into cot x minus 1. Now if we take minus 1, if we take this into this side, here it can be written in this manner. So which implies that we can write this in this manner, that is, take the 1 this side, or we can take it to that side. So cot 2x, I am writing this first, this I am writing it first, cot 2x into cot x. I am taking all these to that side, only the whatever is the constant I am bringing to the left side. So cot x minus cot 3x into cot x minus cot 3x into cot 2x. I took these two to the other side. This as wrote as it is. I wrote this as it is, this as it is, and I have taken these two to the other side, this side. So which is equal to, I can write it as equal to 1. So therefore this is what we have to prove. So hence proved. This is what we had to prove from the question. Yeah, next we'll go into what 23rd, prove that tan 4x is equal to 4 tan x into 1 minus tan square x by 1 minus 6 tan square x plus tan to the power of 4x. So now how do we do this? We'll just see. So solution part, you know that tan 2a is equal to 2 tan a by 1 minus tan square a, isn't it? So now what we are doing is we are going to put a is equal to 2x. So what are we going to get? Tan of 4x is equal to 2 tan 2x by 1 minus tan square 2x. So which can be written as, now you know that tan 2x formula is, again you can expand that. So 2 into, we are expanding the tan 2x formula. So 2 tan x divided by 1 minus tan square x by 1 minus 2 tan x divided by 1 minus tan square. So this is equal to 4 tan x by 1 minus tan square x divided by 1 minus divided by, this will become, if you are taking the LCM, 1 minus tan square x whole square minus 4 tan square x divided by 1 minus tan square x whole square. So which is equal to, here you are getting it as 4 tan x by 1 minus tan square, this will get cancelled, you are getting only 1 minus tan square x. So this will go to the numerator over here. So it will become 4 into 1 minus tan square x divided by, you expand what is 1 minus tan square x whole square using the formula a minus b whole square. So you are going to get it as 1 plus tan to the power of 4x minus 2 tan square x minus 4 tan square x. So this can be written as 4 tan x into 1 minus tan square x divided by 1 minus 6 tan square x plus tan to the power of 4x. And this is what we have to prove, isn't it? So therefore we got tan 4x is equal to, this is the answer. Hence proved. Prove that cos 4x is equal to 1 minus 8 sin square x into cos square x. So if you're going for the solution for this we can write it as cos 2a is equal to 1 minus 2 sin square a. So put a is equal to 2x. Therefore cos 4x is equal to 1 minus 2 sin square 2x, which is equal to 1 minus 2 into 2 sin x cos x whole square, which is equal to 1 minus 2 into 4 means it becomes 8 sin square x cos square x. So this is the answer which we had to prove. So this is, we started off with LHS and this is equal to RHS. So hence proved cos 4x is equal to 1 minus 8 sin square x cos square x. So now going into the prove that cos 6x is equal to 32 cos to the power of 6x minus 48 cos to the power of 4x plus 18 cos square x minus 1. So for this solution it's equal to, here you have, since you know that cos 2a is equal to 2 cos square a minus 1, you put first here a is equal to 3x. Therefore cos 6x is equal to 2 cos square 3x minus 1, which is equal to 2 into 4 cos square x minus cos square, this is cos square 3x, isn't it? So you're having this, you have to write cos 3x and then the whole square of this. So you cos 3x is nothing but cos cube 4 cos cube x minus 3 cos x whole square minus of 1, which is equal to 2 into 16 cos to the power of 6 minus 24 cos to the power of 4x plus 9 cos square x minus of 1. So which is equal to 32 cos to the power of 6x minus 48 cos to the power of 4x plus 18 cos square x minus 1. This is what we had to prove. So therefore cos 6x is equal to